Good morning, students. Welcome to your physics class. I hope you are doing good and are in good health. So let's start with our class. Good morning, students. So far, we have completed all the three laws of motion in detail. In our today's class, we are going to start with law of conservation of momentum. What is the law of conservation of momentum? As the name itself is suggesting that it is a law of conservation of momentum, means momentum will get conserved, means momentum will get unchanged. Okay, that means momentum will not change. What are the conditions where momentum gets conserved or momentum gets unchanged? Let's discuss them. Okay, let's assume that we have two objects, object A and object B. Okay, object A has mass as m. Okay, so I am referring it as ma. Okay, object B has mass mb. All right, remember students, this A will come under this. Okay, this is just the way of explaining that it is the mass of object A and this is the mass of object B. Alright. So there are two objects of different mass. Alright. Now they are having a certain velocities. Okay. Certain velocities. So now since this is the initial phase. Okay. So they will have some initial velocity. So I'm assuming that it is having initial velocity as ua. Okay, in the base I am writing this a. Okay, and this is moving with the initial velocity as ub. Okay, and assume that both objects a and b are moving in the same direction, that is towards right direction. All right, now assume that this object a is faster than object b. Okay, so what will happen? Since object A is faster than object B, so UA is greater than UB. This is showing that object A is moving faster than object B. Okay. Now, what will happen if object A is moving faster than object B? Then at some particular time, the object A will collide with object B. Okay, so while during the collision, I'm assuming that the time of the collision is time t. T is the small time. It may be of very small amount of time that collision happens. Okay, but that time I'm referring as t. T is my collision time, the time during which object A will collide with object B. All right, so this is the scenario before collision. Okay, before collision. All right, so now here I have seen that both have collided. Okay, so now what will happen during the collision? This will be the scenario. Okay, so since A was faster than B, so A came near the B and collided. Okay, so what will happen? A will exert certain force over B. Okay, in the manner like this. Okay, F AB. Okay, what does this FAB means? FAB means the force exerted by A on B. All right, because A was fast, since A was faster, so it had come near to the B and collided. Okay, so what will happen? We know that according to third law of motion, since A had collided to B, so B will also exert the same amount of force towards A. So in return, B will exert a force on A. So B will exert force on A. This is the force exerted by B on A. Alright. And this force, this will be the reaction force. This was what? This was the action force and this will be the reaction force. And both will have similar strength, but the direction will be equal and opposite. Okay. The direction will be exactly opposite, but the strength will be equal. Okay. To every action there is equal and opposite reaction. Okay. So this will be the scenario of during collision. Okay. So what will happen after the collision? After the collision, both will move apart, isn't it? So how will the diagram will be? It will be like this, isn't it? Now this was what? A, and this was what? B. Alright. So now the object A will continue moving, but now the velocity will get changed. Why? Because since both got collided, now their velocity got different. Now the velocity after the collision, I am assuming that this is VA and this is VB. Okay. These are the velocities after the collision. Alright. So this will be the scenario after collision. Alright. Now what was the activity? The activity was that two objects were there. Okay. Now in this entire activity, I am assuming that there is no external unbalanced force is applied. The condition for this experiment is what? That there is no external unbalanced forces acting. Okay. So for discussing the law of conservation of momentum, the condition is that there should not be any external unbalanced force. Okay. That is being applied or acting on this collision. Okay. Now tell me, what if there is an external force acts during the collision? Then the law of conservation of momentum will not hold true. Alright, the law of conservation of momentum holds true only when there is no external unbalanced forces acting. Okay, so let's discuss that how the momentum will get conserved. Okay, so now here we have seen that there are three stages before the collision. Before the collision, the object was having initial velocities as UA and UB. Okay, and their respective masses MA and MB. Okay, and during the collision, what happens? Since the speed of A was greater than the speed of B, so both got collided. Okay, since A has exerted force on B by in the collision, so B will, according to the third law of motion, to every action there is an equal and opposite reaction. So B will also exert the equal amount of force, but exactly in opposite direction. So since A was exerting force in rightward direction, so B will exert force, equal force on B. B will exert equal force on A, but in opposite direction. That means opposite of right is what? Left direction. Okay, so B will exert force on A in the leftward direction. Okay, in terms of FBA. All right. Now after the collision, what happened? After the collision, both got separated and has their and both have their velocities as VA and VB. Okay, so these are the final velocities. Okay, now tell me, since we have already studied about the momentum, isn't it? Momentum is what? Momentum is the product of mass and velocity. Okay, so While discussing the initial velocity, we'll be taking while discussing the initial momentum, I'll be taking initial velocity, and while discussing the final momentum, I'll be taking final velocity. Okay, so tell me, before collision, okay, before collision, what will be the initial momentum? The initial momentum for A, first we are seeing for A. Okay, for A, what would be the initial momentum? Initial momentum will be what? Mass into initial velocity. So for A, the initial momentum would be what? Ma into ua. Okay, so it will be what? Ma ua. Okay, this will be what? This will be initial momentum of object A. Okay, similarly for B, the initial momentum will be what? For B, the initial momentum will be mass into velocity. So mb ub. This will be what? This will be initial momentum of object B. All right. Now here we know, here what was there? FAB will get equal to FBA. Why? Because according to the third law of motion, FAB will be equal to FBA but in of opposite direction. So I'll be writing FAB is equal to minus FBA. Both will have similar magnitude but different direction. Okay, so this we have got from third law of motion, that to every action, what was the action? Action was that A has exerted force on B. Why? Because A was faster than B and both were moving towards rightward direction. So A collided with B and gave the force or exerted the force FAB. So B in return exerted force, equal amount of force to A. Okay, similarly for after collision, okay, for after collision, for A, the momentum will be what? Ma into mass into velocity. Now after the collision, the velocity will be what? Our final velocity. Okay, so VA. Okay, so it will be Ma VA. Okay, now for B, it will be what? MB and VB. Okay, remember students, this A, B, these are always written in the base. Okay, so don't write it as MA. Okay, this is wrong. The representation should be like this. Okay, now we know that force, both the forces are what? Equal and opposite in direction, isn't it? This is what? This is the force exerted by A on B. So it is the force which is produced by A. Okay, and this is the force that is being exerted by whom? By B. So this is the force exerted by A and this is the force exerted by B. So the force exerted by A will be what? F AB. Okay, and the force exerted by B will be what? F BA, isn't it? We know the force is what? Force is rate of change of momentum. So it will be what? MA. Okay, now this will be what? This will be the force exerted by B. Okay, so the force exerted by B on A. So this is basically the force exerted by B. So write the value of it. So it will be what? mb vb minus ub by t. Okay, solve it. T will get cancelled, isn't it? Will be left ma va minus ma ua is equal to minus mb vb and plus mb ub. Okay, now rewrite it. It will be ma va. Okay, bring this minus mb vb here. Okay, so it will be what? Equal plus mb vb. Okay, and it will be mb ub, and bring this minus maua here, so it will be what? Plus maua. Okay, this will be the equation. So just rewrite it. Can I write this right hand side first? So it will be what? maua plus mb ub is equal to what? ma va plus mb vb. Okay, now look at this equation nicely. First term is what? maua. This is what? This is the value of momentum, and this is the value of momentum of a, and that too initial momentum of a. Okay, so this is what? Initial momentum of a. Okay, this is what? This is the value of initial momentum of b. This is what? It is the final momentum of a, and this is what? Final momentum of b. So can I write, since I know that momentum is a singular word and the plural of momentum is what? Momenta. So the sum of two momentum will be what? Momenta. So these will be what? The total or sum of initial momenta of a and b. Okay, this is what? The sum of initial momenta of a and b. Okay, and this is what? It is the total or sum of final momenta of a and b. Okay, so what does this mean? It means that the sum of initial momenta is equal to the sum of final momenta. Okay, that means that during the collision, this initial momentum and the final momentum gets equal. This means that it doesn't get change even from the collision. Okay, so the momentum will get unchanged. Why? Because here it is showing you the proof that the initial momentum remains equal to the final momentum. That means our momentum doesn't get change even after the collision. Okay, and our momentum will get conserved. Conserved means what? Unchanged. Okay, this is what the law of conservation of momentum, that the during the collision also the initial momentum gets unchanged. Okay, and gets conserved. That means it doesn't get change. Okay, and what should be the condition for law of conservation of momentum for this equation to get valid? That there should not be any external unbalanced force acting on both the objects or either of the objects. Okay, there should no any external force is being applied. Okay, so what should be the statement of law of conservation of momentum? It says that the sum of momenta of two objects before collision is equal to the sum of momenta of the two objects after collision when there is no external unbalanced force is acting on them. Okay, so can I say that the total momentum of two objects is unchanged or conserved by the collision? That means collision doesn't affect the, or we can say that collision can't affect the value of momentum. Okay,